Hello everyone. In this video I am going to discuss an important method to solve linear partial differential equation. The method is called separation of variables. This method is very convenient method and therefore we use this method to solve wave equation, heat equation and Laplace equation. In this method we reduce the given partial differential equation into number of ordinary differential equations, and that number is equal to number of independent variables. That is, if the given equation contain n independent variables, then we reduce the given PDE into n ordinary differential equation, and then we solve the ordinary differential equation, which is comparatively easy. And then to get the solution of given PDE, we multiply the solution of ordinary differential equations. Let us see how to perform this method to solve linear partial differential equation. Consider a partial differential equation containing n independent variables x1, x2, x3 and so on xn, and one dependent variable u. First we consider the given partial differential equation has a solution of the form u equal to function of x1 into function of x2 into function of x3 and so on function of xn. That is, the given equation has a solution as the product function of independent variables. And now this is the solution, therefore it must satisfy the given PDE. So we calculate various partial derivative from this relation as required and putting in the given PDE. It reduces the given PDE into number of ordinary differential equation. Now we solve the ordinary differential equation, and finally the product of all solutions of ordinary differential equation gives the general solution of given PDE. This method will more clear in following examples. Solve the equation by method of separation of variables. Equation is del u by del x equal to 2 times del u by del t plus u, where ux comma 0 is 6 times e raised to minus 3x. This is initial condition using which we get the value of arbitrary constant. So the given equation is del u by del x equal to 2 times del u by del t plus u, and we are going to solve this equation by method of separation of variables. And since this equation, this partial differential equation contain two independent variables, small x and small t, so first we consider the solution of given PDE in form of product of function of independent variables. So let u equal to function of x into function of t be the solution of equation first. Now we calculate the value of del u partial derivative del u by del x and del u by del t from second. So del u by del x, partial derivative of u with respect to small x. So here capital T is function of small t, therefore this is constant with respect to small x, so t is here. Now partial derivative of capital X with respect to small x is d capital X by d small x. Because of x is function of single independent variable small x, therefore the partial derivative is same as the ordinary derivative. And similarly del u by del t, the partial derivative of u with respect to t. So in this case capital X is a function of small x, therefore it is constant, and therefore we multiply capital X, and the partial derivative of capital T with respect to small t is dt by d small t. Again t is function of single independent variable small t, Therefore, the partial derivative is same as the ordinary derivative. Now, putting the values of del u by del x and del u by del t from third into first, we get the value of del u by del x is t dx by d small x and equal to 2 times the value of del u by del t is x in capital X into dt by d small t plus u. The value of u is capital X into capital T. Now taking x common in the right hand side, we get t d capital X by d small x equal to capital X into 2 times d capital T by d small t plus capital T. Now we have to separate the variables. So we divide this expression by capital X into capital T. So here when we divide by xt, we get dx upon d small x divided by capital X equal to, here capital X is cancelled, so we divide this by t, capital T. So we get 2 times d capital T by dt upon capital T plus here t cancel, so we get 1 equal to k. Now taking first and third part, we get d capital X upon d small x upon capital X equal to k. So transfer d small x into right hand side, we get d capital X upon capital X equal to k time d small x. So variables are separate. So now we integrate this, we get log capital X equal to k small x plus constant of integration log c1. Apply the property of log, we get capital X is equal to c1 e raised to kx. Now we take second and third part, we get 2 times dt by d 2 times d capital T by capital T equal to, this is k minus 1 and d small t we multiply in right hand side. So we get this expression. Now variable are separate, so we integrate, we get 2 times log capital T equal to k minus 1 times small t plus log c2, say c2 square constant, and apply the property of log, we get t square equal to c2 square into e raised to k minus 1 t. So the value of capital T, from this we get t equal to c2 into e raised to k minus 1 by 2 t. Now the final solution of given PDE is the product of these two solutions. We get u equal to c1 e raised to kx, which is the solution of first ordinary differential equation, into c2 e raised to k minus 1 by 2 t, which is the solution of second ordinary differential equation. So the product of solution of ordinary differential equation gives the general solution of given partial differential equation. This solution we also write u equal to c1 c2, which are the arbitrary constant, into e raised to kx plus k minus 1 by 2 t. Now we are given the initial condition ux comma 0, that is the value of u when t is 0. So ux comma 0 is given as 6 times e raised to minus 3x, that is at t equal to 0 the value of u is 6 times e raised to minus 3x. So putting t equal to 0 in 6, and in that time value of u is 6 times e raised to minus 3x. So we get 6 times e raised to minus 3x, and when t equal to 0, this expression is 0, we get c1 c2 into e raised to kx. Now simplifying this, we get c1 c2 equal to, comparing, we get c1 c2 equal to 6 and k equal to minus 3. So putting the value of c1 into c2 and k in equation 6, we get u equal to 6 times e raised to minus 3x minus 2t. So this is the final solution. This is the general solution of given partial differential equation. Next question is, solve the equation by method of separation of variables. The equation is del 2u by del t2 minus 2 times del u by del t plus del u by del x equal to 0. This is a linear partial differential equation of second order, and we are going to solve this equation by method of separation of variables. So the given equation is del 2u by del t2 minus 2 times del u by del t plus del u by del x equal to 0. And since this equation contains two independent variables, small x and small t, so therefore we consider the general solution of equation first as the product function of independent variables. So consider the solution is u equal to function of small x into function of small t. Now we calculate the partial derivative del u by del x, del u by del t and del 2u by del t2 from second. So first we calculate del u by del x, the partial derivative of u with respect to small x. Since capital T is function of t, small t, therefore it is constant with respect to small x, and therefore we multiply capital T as it is. Now the partial derivative of capital X with respect to small x is d capital X by d small x. Because of capital X is function of small x only, that is contain only single independent variable, therefore the partial derivative is same as the ordinary derivative. Now del u by del t, the partial derivative of u with respect to small t. Here capital X is function of small x, therefore it is constant with respect to small t, and therefore we multiply capital X as it is. Now the partial derivative of capital T with respect to small t is d capital T by d small t, and again capital T is function of single independent variable small t, therefore partial derivative is same as the ordinary derivative. Now the second order partial derivative of u with respect to t, that is del 2u by del t2. So we again differentiate this expression with respect to t partially. We get del 2u by del t2 equal to capital X is constant with respect to small t, therefore as it is. Now the partial derivative of d capital T upon d small t is d2 capital T by dt square. Now putting the values of all partial derivatives from equation third into first, we get the value of del 2u by del t2 is capital X d2 capital T upon d small t square minus 2 times the value of del u by del t is capital X into d capital T by d small t plus value of del u by del x is capital T d capital X upon d small x equal to 0. Now we have to separate the variables, and therefore we transfer this expression into right hand side and then divide the whole equation by x and t, capital X and capital T. So in left hand side capital X is cancelled, so we get 1 upon capital T multiplied by d2 capital T by dt square minus 2 times d capital T upon d small t equal to, in right hand side capital T is cancelled, so we get minus 1 upon x into d capital X upon d small x equal to k. Now taking first and third part and second and third part, we get 1 upon capital T into d2t by dt square minus 2 times d capital T upon d small t equal to k, and here from the second and third part we get minus 1 upon capital X del capital X upon dx equal to k. Further, we transfer capital T into right hand side, here we get kt, and then transfer whole expression into left hand side, we get del 2t by dt square minus 2 times d capital T by d small t minus kt equal to 0, and from this relation we get d capital X upon d small x plus kx equal to 0. So these are two ordinary differential equations corresponding to the given partial differential equation. Now we solve these two equations. Equation 5 is linear differential equation with constant coefficient, and therefore its solution capital T is CF plus PI. Further, the right hand side of equation 5 is 0, therefore PI is 0, and finally the T equal to CF is the solution. Now the equation 5 also can be written as in form of the operator capital D square minus 2 times capital D minus K whole multiplied by capital T equal to 0. Now to find CF, the auxiliary equation can be obtained by putting D equal to M. So the auxiliary equation is M square minus 2M minus K equal to 0. The roots of auxiliary equation can be obtained using the discriminant method as M equal to 2 plus minus square root of 4 plus 4k by 2, that is minus b plus minus square root of b square minus 4ac by twice a. Further we simplify this relation, we get 1 plus minus square root of 1 plus k. So the roots are real and distinct, and therefore the CF is C1 e raised to m1x m1t plus C2 e raised to m2t. So this is the CF, and T capital T equal to CF is the solution, and therefore the solution of equation 5 can be expressed as capital T equal to CF plus PI, PI is 0 and therefore CF only. So this is the solution of equation 5, that is the solution of first ordinary differential equation. Now we obtained the solution of second ordinary differential equation, which is d capital X upon d small x plus kx equal to 0. Simply we separate the variables, we transfer this k capital X into left hand side, and then we get d capital X upon capital X equal to minus k times d small x. So the variable are separate, and therefore solution can be obtained by integration. So we integrate this expression, we get log capital X equal to minus k times small x plus log c, constant of integration. And now apply the properties of log, we get capital X equal to c into e raised to minus kx. So this is the solution of second ordinary differential equation. And as we know, the general solution of given partial differential equation is the product of the solution of ordinary differential equation. Therefore the general solution is u equal to This is the solution of first ordinary differential equation into the solution of second ordinary differential equation, and this further can be written as u equal to, we multiply this expression in the bracket and then we get this relation where capital A is constant C1 into C and capital B is C2 into C. So this is the general solution of given partial differential equation using the method of separation of variables. In next video we discuss the solution of wave equation, heat equation and Laplace equation. Thank you.